Hannah Downert with the Collaborative on Health and the Environment. She enjoys bringing you the latest environmental health science through our partnerships, calls, webinars, science serves, publications, and social media. I would like to welcome everyone to Che's partnership webinar titled Improving Water Quality in Schools and Childcare Facilities During COVID-19. Our moderator is Karen Wang, Director of Che and founder of Because Health. We will leave time following the presentation for a brief Q&A session. You may type in questions through the Q&A feature available on the top of the menu bar in your window at any point during the presentation. After the presentation, our moderator will read out questions for our speakers to respond to. We will get to as many comments and questions as we can during the Q&A period. For those of you who called in on the phone, we have posted slides to accompany today's webinar on our website. You can download these by going to healthandenvironment.org. Please scroll to the bottom of the page and select today's webinar. On the webinar page is a link to the slides. Everyone on the webinar right now is muted with the exception of our speakers. This webinar is scheduled to last for 60 minutes and is being recorded for our call and webinar archive. With that, I'll pass things over to you, Karen.
Great, thank you so much, Hannah. As school buildings begin to open up after an extended shutdown due to COVID-19, employees and families are dealing with unprecedented questions about building safety. We had a previous webinar on safer cleaning and disinfecting. You can find the recording on our website. And today we're going to talk about water. Water in school buildings is critical to public health protection through hand washing and drinking water. And we are very excited to have two water quality experts with us today. The first is Dr. Nancy Love. She is the Borchardt and Gleason Collegiate Professor of Civil and Environmental Engineering at the University of Michigan and an adjunct professor at the Institute of Biotechnology at Addis Ababa University. Her research focuses at the interface of water, infrastructure, and public health. She and her students evaluate the fate, detection, and treatment of chemical and biological contaminants in water systems and advance resource recovery technologies. Our second speaker is Elin Betanzo. She's the founder of Safe Water Engineering, LLC, a small consulting firm working to improve access to safe drinking water through engineering and policy consulting. Elin's work focuses on raising awareness of lead in drinking water, assisting water utilities with Safe Drinking Water Act compliance, and improving drinking water regulations and legislation at the state and federal levels. And with that, I'll give it over to you, Nancy, who's our first speaker today.
Thank you, Karen. I'm really happy to be here. What I'm going to do is really set the stage for Elin, who's really an expert in the indoor plumbing and has been working very diligently on thinking about and working on water in school buildings and ramping up. And I think it's important to understand the school building in the context of the system in which it sits. So I will talk about that, and then I will spend a little bit of time talking about filtration and hydration stations, such as is shown on this, this first slide, where there are, in most cases, filters inside, why they're important, how they work, and some of the things we need to consider in order to ensure that they perform the way we want them to and produce high quality water. So I'm going to start first by, again, talking about the system. A school building sits within a larger water system in a community. And the points I want to make to you is that the water for your community comes from one of two places. It's a surface water or a groundwater, or maybe a combination of both. Either way, the environment that water system is in influences its quality, as well as how the land is used around the water source. Weather affects the water quality, but no matter what that is, and of course it can vary across the year and it can vary from day to day depending upon the weather, that water comes into a very complex and what's called a multiple barrier drinking water treatment system. These systems are designed to remove multiple different contaminants, including biological contaminants and chemical contaminants, particles, and produce the water that goes into the distribution system that comes to our homes and our buildings and our schools and comes out of the taps. The distribution system also then results in them going down the drain into a collection system, which can also be affected by weather, and then gets treated as wastewater and then goes back into the environment to become ultimately, after treatment, the water source for another community. So we're within this larger system is where our schools sit, and it's different from community to community because of the source of the water and the way in which it's treated. And so one of the messages I want to send is that it's important to understand where our schools sit within the system and to know a little bit about your community, because some communities, I think, are in a situation where the treatment and the distribution systems are maybe younger and or producing high quality water out of treatment that is maintained throughout the distribution system. In other cases, we may have some challenges within our distribution system and or the plumbing inside the building, which is called premise plumbing, that we need to be mindful of, and then we need to start really making sure that our management plan in the school addresses those challenges in order to ensure that we have water that's fresh coming in from the distribution system. I am a little worried that I have, oh no, I'm good. So it's a typical distribution system. I'm just showing you a picture. And what this is reflective of are the pipes that take the water from the treatment plant. In this particular case, the treatment plant is sitting kind of in the middle of the community. And then it pushes the water out in all these different directions in pipes. And those pipes are underneath our streets. And so if this looks like a street grid, it should, because that's where the pipes are. You have oftentimes a pump station that will add pressure, and we need pressure in our water lines to keep the environment from leaking in. We don't want that to happen. So as long as there's pressure in the pipe, any leakage would be out of the pipe and not in from the environment. If we have a line break, then we have an opportunity for water or other things to come into our pipes, and we have to decontaminate before that water can come back online. We can also have storage tanks, and we often see these in our communities that provide that kind of pressure and elevation for our communities. So this would be the typical, what it looks like if you were to map it out, and it links in with the map of the community. But if you kind of go underground and think about the different parts, you have your source. This shows a surface water source. It could be a groundwater source. You have your treatment plant, which then pushes it out in large transmission mains. And those transmission mains sometimes have booster pumps that enhance the pressure, but then they will tap off of the transmission main into a distribution main. And then a water main that is in the street from which our buildings tap into. And the utility is responsible for everything in blue, and then the building owner is responsible for everything in yellow. So what we refer to as the piping that comes into the building is a service line that comes from the street into our building. And then inside the building is the plumbing in our building, and that's called premise plumbing. And we know a lot about treatment systems. We know a lot about water quality and pipes, although there's still things we don't know. We know a lot less about water quality and premise plumbing and the actions we take or the material effects on that plumbing. There are some things we definitely do know. We do know, and I think Elin will get into this, we do know that lead is bad and that lead is present kind of in a lot of our systems, even in lead-free plumbing, and that we have to take action around that, especially when it comes to schools. And I think Elin will address that. But kind of keeping it at the system level, I wanted you to have an understanding of all these different pieces and to remember that the water main is under the streets where the buildings are. So one of the things I think is important as you think about schools and the water quality coming into the school is where that school sits in the overall map of a city. So let's take a look at a Google map of a community. And this is what a normal community might look like. This is a residential sector. You have the streets and you have a completed residential sector with houses and neighbors and so forth. And so it's very complete. the water distribution system was designed assuming growth. And so it was designed even before all these houses were there, but to provide water at the pressure needed to maintain the quality and maintain disinfectant in that water, so that when it comes out of your tap, you have the water quality that the drinking water treatment plant intended for you to have coming to your house. If you zoom down to the street level for that community, it might look like this, where the line is underneath this street, and then you're tapping off at every one of these houses, which have people living in them, and they're constantly pulling water throughout the day. We might have less pulled at night, depending upon the community, but that water is moving through the pipes, and movement of water, non-stagnant water, is really important to maintaining fresh water with disinfectant residual. Let's look at another community that's different from the one on the left. This is a community where you see there aren't as many houses around the streets. This might be what we would call a shrinking community, or a community that has reduced population. It had peaked at one point, and for various reasons, sometimes job loss, sometimes industries have left. The community has decreased, and as a result, not all homes are lived in, and consequently, many cities, they will raise or remove those houses. You still have the pipes that connected them to the main. The main is still in the street, and so ideally, you have put concrete in that line so you don't get environmental factors coming into the pipe. But in communities that are economically stressed, sometimes you know, we wonder if that's been done correctly. So let's zoom down now on the community on the right and see what that one looks like on the bottom. You still have a water line in the street. It was designed for growth when the community did peak, but now you have houses that people are not living in, houses that have been removed. In this particular picture, there is one house pulling water out of that main that was designed for a street full of homes that were active and people were using the water. So in this case, the water pressure still has to be maintained, but you have the water spending more time in the pipe. And so depending upon the material and so forth, that will affect the water quality. The time water spends in a pipe is called water age. And water age ends up being a very important factor in any community in terms of how water quality changes from where it's treated to where it ultimately comes out of the tap. And so I'm going to show you a map of a community that has been modeled by engineers. This is something from my colleagues at Wayne State for a community they've worked in. And in this map of the city, it's a geographic map of the city, but its colors reflect the water age in different sectors of the city based upon how the pressure and the hydraulics work in that particular city. And this is a city that has experienced shrinkage. So I show this specifically as kind of a worst case scenario where you have the green areas reflecting good water age. So typically by design, we would prefer that that only takes no more than about 2 days from leaving the treatment plant to coming out of your tap. And in this case, we're seeing the dark and light green being 1 to 2 days. But when you start getting into the yellows and the pinks and then the very light pink, we're now talking 2 to 3 weeks. And when you have that, you now have very high water age and very significant water quality changes. So where your school is within a community like this, it's important to have a handle potentially on where it is relative to the distribution system or what we know about it. And not all communities have a great handle on this, I will just say. So why is this important? We've known for decades that water age or storage reduces the quality of drinking water. These are the different kinds of factors as examples of what can happen to drinking water that is stored or is at high water age beyond the few days that we prefer in our system. And the bolded words are those that have a direct impact on health. The corrosion control effectiveness is basically lead. So if we don't have corrosion control, we're exposed to metals like lead. Disinfection byproduct, the disinfectants we add to remove the microbial or the germs that might be in our water that are very effective at killing them, can also react with other materials in our water to form some chemicals that, if at too high a concentration, can be harmful. And if we have high water age, that really falls in here, microbial regrowth and recovery. If the water age is very high, then the disinfectant will dissipate over time and you could have more microorganisms growing. This is where it becomes really important with this premise plumbing, because we can control the distribution system, but we can't control what goes on in a building unless people are actively using the water in their building and flushing it, which is what becomes really important when we talk about schools, especially schools that have been shut down for some period of time. This is not a normal kind of status, I think, for many schools, except for summer break. So there is some experience there, but I think it's really highlighting with this COVID situation the need to really pay attention to what we are doing to get buildings back online. So water quality is impacted by that premise plumbing, and it's a function of where the building is in the city's hydraulic map. So I'll finally kind of talk about a few things that sometimes is done, and that is to, inside the building, if we have concerns about the water quality, be it because of what's going on in the distribution system and we have high water age, or if we are concerned about lead that might be leaching from materials that are used in the distribution system or the premise plumbing, or the service line in the premise plumbing, then we might use point of use solutions. And in schools, you're increasingly seeing what are called hydration stations, which are stations that are like bubblers, water fountains, but also give you an opportunity to fill a water bottle. And this hydration station I'm showing you has a filter down here on the bottom that should be used. I have seen cases where they don't put the filter in there, but the filter should be in there, okay? And that's a good thing to confirm. So I'll talk a little bit about this filtering. These hydration stations, the filter that's used in them is called an activated carbon block filter. I'm showing you a picture of it here. They take the charcoal, which is a very good sorbent and very good at removing lead and copper, and they fuse it with a polymer to create these cylinders. It's the same thing that they use in the hydration stations that you might find in your school or an airport or a public space. Is the same material they'll use in the point of use filter you might screw onto your faucet in your kitchen. And sometimes they have a wrap around them, a material, a fabric wrap to hold that carbon, the fines together as they manufacture the unit. Sometimes they don't. And then the water comes in and it goes to the outside and it goes radially through the cylinder into the middle, which has this annular hole, and then the water comes out, and that's your cleaned water that's gone through the activated charcoal. These systems are certified by the National Sanitation Foundation and ANSI. There's some very clear, stringent requirements. You should always look to see that the units that are being used have been certified through these agencies. The two main certifications I'm showing here relate to the health of the water and the aesthetics of the water. And I bring this up because there's been a lot of work done showing how to implement the activated carbon block systems to remove heavy metals like lead. And so that works very well. Our experience in both research in laboratories as well as in communities where we've measured use of these activated carbon block filters in systems that have lead in the water do an excellent job of removing lead below detection as long as the system is maintained. And that's the key. The thing that I want to point out is that there are not, other than like larger microbial organisms, the bacteria and viruses are not part of these standards. And so they're not, because it's known that the activated carbon block is actually not going to remove them. And in some cases, depending upon, again, where you are in your distribution system and the quality of water that comes into your building and the way you maintain the water in your building, you can get quite a bit of microbial growth in these filters. And not, a lot of those microorganisms are perfectly harmless, but if your water quality coming in is challenged because of high water age or other factors in the community that have decreased the quality of that water, you could have pathogens that grow in the filters. And we have seen this in some communities. And so it's really important to maintain your filters. If you maintain the filters and you flush them, you can push that through and overcome those challenges. So what does that mean? This is just some data, but it shows you on the y-axis, I'm showing you an indicator of bacterial counts, how many bacteria are coming out of a point of use filter. This was a laboratory study, but we've seen this repeated in community-based studies. And then we're showing time of use. So these filters that I was working with in this case with my collaborators typically lasted 1 to 2 months. And so you see we ran this out for the entire duration of its lifetime, about 100 gallons in this case. And the dashed lines show for 3 replicate filters the typical bacterial count in a typical community drinking water. We see this is very common, about 100 cells per milliliter. But what the filter does is it allows that growth, and you'll see very quickly, well before the end of the lifetime of the filter, that the counts go up about 100-fold. Now, again, these may not be harmful bacteria. It all depends upon how your system's maintained. Is there disinfectant residual coming into the building? The filters themselves will actually remove the disinfectant residuals, so the bacteria are actually growing in the filter and on its surface in ways that the disinfectant residual is gone, and so there's nothing to stop that. So that's why the maintenance becomes really critical. And I'm showing kind of some complex things in terms of biology that we do, but the main point here is look at the changes in color. So it's very important, I'm gonna actually go to the next slide to know that what a filter does is the colorful bar on the left shows you every different color is a different kind of bacterial group. And so this is what the Drinking Water Treatment Plant gave you and passed all the State Drinking Water Act regulations and was what was exposed to the disinfectant. In the middle is the bar of the bacteria that are on the filter itself. And you see the colors have changed because the organisms that survive that are very different and they grow. And so the distribution changes dramatically. So this bar here was very small and now it's very large because it's a large fraction of the population now. And then after it goes through the filter, this is what comes out. So the point is that a point of use filter will change the microbial composition of your water. And what we want to be sure is that none of those pathogens make it through and come out that water. So we found that if you maintain the system again and you do your flushing and you change your filter cartridges when you're supposed to, you will reduce that effect by quite a bit. I will point out the different kinds of organisms. I'm not spending a lot of time on that, but we have done work looking at Legionella in these point of use filters. And in the cases where we looked at them, Legionella did not accumulate heavily in these filters. We did see other opportunistic pathogens that did accumulate in these filters, but they tend to be bacteria that are more of a problem if the water is sent out of a shower. But I think the point is that we know that they can survive in these filters if you're not maintaining the building water system around you or the filters in the hydration station themselves. And so you do that, and I think the chances for any kind of problem with this is greatly reduced. So this is just showing you in a big institutional building, a university building, like a school, like a K-12 school, what flushing will do for you. So this on now on the bottom, I have seconds on this axis. And on the right, I'm sorry, the left axis, I'm showing you cell counts using a different type of measurement. But it's the same kind of graph I showed you before, where this was what was the time 0 is what's coming out of the filter. And you can see over time, like we started this in November in this particular year. And then as you went from time up to December and January, the actual concentration coming out of the filter is growing because you have that growth happening in the filter over time. But what I want you to focus on is the first 30 seconds. If you flush that filter, you decrease your cell counts by at least 10-fold and maybe more. So the flushing is a really important part of using any kind of filtered system. So on the point of use filter side, you have to think about where the building is that the filter is in within the overall system. Water age is really important, and your utility should have a sense of which schools are in high and low water ages if you want to know. But either way, that the whole concept is that if you have high water age, you have the potential for reduced disinfectant residual, and so you want to make sure you pull in water from the distribution system to maintain water in the building that has disinfectant residual, and that will reduce these bacterial buildups. This is really too busy, so I won't go there. But I think the point, I also want to just close by saying, and I think Elin will probably get into this, schools are not community systems. And so when it comes to the regulations, they're not part of the regulations. We don't monitor inside buildings, and we know a lot less about water quality inside buildings. Although there are people working on this for sure, there's still a lot of variability there. We do know, though, what are some good maintenance practices, and that's what Elin's going to get into. And if you use those maintenance practices, you should be able to dramatically reduce risk associated with these systems. So I will stop sharing myself, and I'll mute, and Elin, take it away.
Thank you so much. While Elin's pulling up her slides, I'd like to remind everyone that you can put your questions into the Q&A feature on Zoom. Feel free to start asking questions now, and at the end of the webinar, we will get to those. Karen will moderate and go through the questions that you might have. Great, and Elin, feel free to share your slides when you're ready.
Okay, I'm unmuted, and can you see my slides?
Yep, they look great.
Great, thank you. So I'm going to get into more of the practical piece of what we should be looking at about water quality in schools as students are returning and schools are beginning to open up again after this extended water shutdown that we've been having over the past several months. So Nancy kind of set the stage here with the types of water quality risks that can develop over the extended school shutdown. So the real issue here is water age, stagnant water, and that water loses its disinfectant residual. That's because it's forming disinfection byproducts with organic matter. When that disinfectant goes away, it allows microbial growth and biofilms to develop inside the school plumbing. The microbe of greatest concern would be Legionella because it can result in Legionnaire's disease, and the big risk there is through inhalation of water droplets. Also, when the water sits still in the plumbing, it allows corrosion to happen. Corrosion control treatment requires regular turnover of the water in the plumbing to reduce corrosion. So any lead that is in contact with the water, copper, and other metals in that premise plumbing can leach, dissolve into the water, and flake off from the plumbing into the water. And then as you have these issues on the inside of the pipes, it can compromise the integrity of the plumbing, leading to leaks, which can result in mold growth in schools. I'm not going to be covering mold at all, but it is a risk that can develop during an extended school shutdown if the plumbing hasn't been maintained or observed over the time when people are not in the building as they normally are. So why is the water quality in schools different this time around? As Nancy said, we usually have school shutdowns. We have reduced water use in the summers, and schools are used to that, but usually that's about 2.5 months. I know in my area, schools have been shut down since the beginning of March, so we've got 6 months of no normal use in schools, and we're dealing with this unprecedented pandemic, and that extended shutdown in this case can mean zero water use in the schools during the school shutdown, when in a normal summer you might have had administrative uses, you might have had summer camps. This summer was not normal. And as we're dealing with the pandemic, there is new information daily. This 6-month shutdown that we're dealing with, we don't have normal standard protocols to deal with these types of water quality situations, and schools are always dealing with a lack of resources. So that these are kind of compounding the water quality issues right now. We have lots of large buildings that have been having plumbing concerns, water quality concerns as they open back up. But when we talk about schools and childcare facilities, we're talking about vulnerable populations. So looking at childcares and young elementary, infants to 6 years old are the age ranges that are most vulnerable to lead in drinking water, lead exposure. So that's definitely a real concern for those vulnerable populations. But also as we're looking at staff and teachers who are coming in, they can be older and more susceptible to Legionella and Legionnaire's disease. So we need to be very mindful that we're dealing with a population that's more sensitive than the population at large, dealing with general building plumbing issues. So the good news about these water quality risks that we have had during the shutdown is that they're all addressed with the same basic theory. The water needs to keep moving. So flushing programs are the strategy to keep that water moving, bring fresh water in, and push the old water out. The complexity of a flushing program depends on a lot of different factors. School buildings and childcare facilities have a very large range of factors that could come into play. So the age of the building and the plumbing materials that are used. The older the building is, the more likely there is to have high lead content in that building plumbing. Water temperature, the higher the temperature, the more the chemical reactions. So higher microbial growth and faster corrosion. So if we're talking about schools that don't have air conditioning, that can be another risk factor there. There's the layout of the building, how many floors there are, how the branching is, the plumbing complexity, and how the water moves from one area to another. Schools need to consider whether there's any on-site water treatment, like a water softener, the number and location of hot water tanks, and other water using appliances that need to have the water turned over while they're flushing the plumbing. Those can be separate from the plumbing itself. And so then another thing to consider as looking at flushing and reopening school buildings is what have the maintenance practices been during the shutdown. The success at a school is going to improve with the availability of facility staff and a good familiarity with that plumbing. It's the less resources the school has available to deal with that makes it more complicated. But the more maintenance there was in flushing water use during the shutdown, the better position the school will be for reopening. So a key point to consider is the longer the water was shut down, the longer it takes to restore water quality. So if nobody's been in the school during this time and the water hasn't been moving, then additional care has to be taken with reopening. It is also important to consider who is using the water in the school and where they are using it. So schools in my area have been open for some limited uses that is very different from normal water use, especially over a summer period. So there are some buildings that have limited spaces that are open for food preparation for the summer meals programs. There's childcare areas that are open. So very small portion, like of a much larger building is active. Summer athletic practices have been going on and they require some access to bathrooms and hydration for those students. So there may have been some limited water use going on that might be starting up right now as schools are phasing in. So it's important to consider who is using the building, where they're using the water, and if there has been or should be a building-wide flushing program right now to be maintaining the water quality for those limited users. Again, the quality of the water right now depends on the maintenance practices during the shutdown and during these limited uses. So especially if these very limited uses are going on in schools, it is important that these users know to bring water from home for their drinking. And that the school water may not be moving like it would normally be during the school year. A lot of people don't think about that, so they need to be told. But they also need to be encouraged to use that water for hand washing and non-potable uses. So this is, that communication with the people using it, considering their specific risk factors, is very important. So in flushing, there is kind of a continuum of different strategies and goals for flushing that you can use in a school building. So I'll start describing the most intense flushing procedure to the least intense. And so the frequency of these also varies. So the most intense and planning heavy strategy would be what we call unidirectional flushing. This is an approach to flushing that you would not use on a regular basis. You might do it once or twice a year for just a basic maintenance. And the idea here is you're working to achieve a certain flow rate in the pipes to scour out sediment that's built up or biofilms that have built up in the pipes. You only want to do this if you know your pipes are in good shape, because sometimes increasing that water flow can be damaging if there's plumbing that's not in good condition. So if you're going to take that, make sure the plumbing can handle it, but it is very effective for moving sediment and biofilm through that plumbing. A less intensive strategy, but very important, especially as we're restoring schools, is refreshing the water in the entire building. And this requires planning, because you want to calculate the volume of water that is held within the school and make sure you're turning that over and even applying a safety factor. And especially if the school is not in service, doing that type of carefully planned turnover of the water, even weekly, is important to keep that disinfectant residual in the building plumbing so that you prevent microbial growth, prevent the disinfection byproducts, and try to keep some corrosion control moving in the school. And then kind of the least intensive strategy would be for simulating typical use. And this would be kind of a more casual operating every outlet, making sure the water is moving through every single tap that's used for water. And so if you're using that strategy, especially making sure that water is moving in unoccupied classrooms, doing that daily to simulate that typical use. There are even some companies that have developed auto flushers that could be used for this type of flushing to improve the water quality in the school. And so if you have a copy of these slides, each one of these has a link to an example of a different guidance document that walks you through that process. So in my area, I have seen like 3 major strategies for reopening schools. And so your water quality needs and your ongoing maintenance is going to depend upon the type of reopening plan you have in your school district. So at one extreme is the return to school, where everybody is coming in using the building as normal. Then there is the hybrid program, where there might be, a school district might offer an online option and an in-person option. Maybe they have half days to limit the number of students in the school. And that's really going to change typical water use patterns in the school. So if students are only there for a half day, even if it's 2 half days worth of students, they might not even have to go to the bathroom during that time. So we have to consider how the use of the building is going to affect typical water use in the building. And then there is the all virtual instruction model, where everybody is doing all online learning. That doesn't mean you can ignore the water quality in the building. You want to keep it moving, because one day you will reopen that school, and you want to, the more you're doing maintenance there, the better the quality water will be ready to accept students in the building. So those are the kind of 3 bins that you could put return to school plans into. So for each one of these, you would want to consider whether unidirectional flushing is appropriate as a starter to clean out the plumbing and start fresh as you're going forward, maintaining the water quality there. If you're going to have a full population of students and staff in the school, absolutely want to keep the water moving. It's possible that the ongoing use with your normal activity is going to be enough. But again, if the water has been shut down all summer, you want to have that water turnover plan happening several weeks before students are in the building. So if you don't have several weeks between today and when students are entering the building, you really want to consider that water quality before you're telling students it's okay to drink the water when they return to school. So advising them to bring their own water bottle, providing bottled water might be very important if you've got a short window between beginning these maintenance procedures and inviting students to the building, and staff, anybody who might be using it. In the hybrid program, we're kind of somewhere in the middle. Consider whether unidirectional flushing is a good strategy prior to opening the school. But in terms of keeping the water moving, you may not have enough normal water use with that decreased student population to get that turnover. So implementing that calculated weekly, I'm going to turn over the entire volume of water in the school building, that might be appropriate and necessary there. Again, if you're just starting your water maintenance now, have an alternative plan for what students and staff are drinking when they come back into the school. Then in the all virtual instruction, if the water, especially if the water has been shut down all summer, it's time to start a maintenance program, do that weekly turnover of all the water in the building. And then when you are ready to invite students back into the building, explore whether a repeat unidirectional flushing procedure would be appropriate. So here is an overview of the steps of restoring water service and doing that flushing. So you would have additional steps if you're doing the unidirectional flushing to achieve specific flow rates. But first of all, you want to check the plumbing integrity, make sure that nothing's been damaged or leaks have happened, because once you start the water flowing, you don't want to flood your school. You want to make sure that all the drain traps are filled with water if they have dried out during the period of no water use in the school. Mapping or sketching the plumbing layouts in the school to know how the water flows from one area to another, so you can design your flushing to bring fresh water in and push the old water out. Start with the cold water plumbing, flush by zone, remove the aerators so you can flush sediment out and not trap any sediment that's in those pipes. Then moving towards the hot water tanks, do any maintenance that's necessary on hot water tanks, and then flush the hot water plumbing. You need to work through all of your water using appliances and making sure that volume of water is turned over. If there are any filters in the building, if they're the bottle fillers or those hydration stations that Nancy talked about, make sure all the cartridges are replaced, even if they were replaced near the end of the last school year. It's been a long time. They need to have fresh filters, and that can also be faucet mount filters or pitchers, depending on what might be in place in the school or childcare facility. And then there are all the non-drinking water systems to maintain. You do that according to the manufacturer's specifications. So I keep talking about the need to bring fresh water in. You want to use the fresh water to push the old water out. And so as Nancy had gone through, we have the water service line. We've got a water main in the street and a service line, and many school facilities can be very far set back from the water main. And those service lines are can have a large diameter because they have to bring enough capacity to that school. So there can be a very large volume of water in that service line. You want to get it out of the way before you start pulling water into the school. So locating the taps that are closest to the service connection to the school and flush those first. Calculate the volume in that service line and turn that over entirely before you do anything inside the school. And then once you are working in the school, you can map it out, see how there are different zones in the school. Here's one example of one map of how water travels. And then you flush by zone. So once you've brought the fresh water in from the service line, you're bringing fresh water to each zone. You're not pushing old water from zone to zone around the school. It's more effective, the fresher water that comes from the main. So then Legionella and hot water tanks. If we don't have a high Legionella risk, the hot water tanks can kill any Legionella that may have grown inside a school building. Again, the greatest risk of Legionella is from inhalation of water droplets. So cooling towers, showers, these types of water sources are where you are likely to find Legionella risk. A water tank has to be at 140 degrees Fahrenheit to kill any Legionella that may have grown. If you've got facility staff, use them to drain and fill the hot water tanks to make sure they're in good operating condition. Make sure you've got a professional there. Sometimes there's sediment issues. The water temperature can change from the tank to the tap as it travels through the pipes. You want to make sure that the water temperature is at least 120 degrees at the tap to kill Legionella that might have grown in the plumbing between the hot water tank and the tap. But then, we're dealing with small children and we're concerned about scalding risk. So checking the local requirements, what you've had in the past for addressing scalding risk, if there's a temperature adjustment to deal with after you've flushed the hot water is appropriate. There might be requirements and recommendations from the local health department about how to deal with that. If you have a high risk situation where you know about Legionella, definitely bringing a professional in to consult with this. You can do testing in the building, and shock chlorination can be an option, but only do this with the assistance of an expert. Lead in drinking water is definitely an issue and a concern as we reopen schools. We need a regular turnover of the water for any corrosion control to work. And most of our plumbing in schools contains lead. There's a lower risk of high lead in plumbing after 2014, schools built after 2014, but in general, we can just assume that there is lead in the plumbing in our schools, especially those built prior to 2014. In schools, in the first place, we already had irregular water use patterns even before this shutdown, with our weekends off, week-long breaks, summer breaks. So corrosion control was already a difficult factor to maintain inside schools. And if water has been off, some estimates show that it's at least 12 weeks or more of regular water use to regain corrosion control in the plumbing. So in this case, it's the safe approach is to assume there's lead in the water, provide filtration, or advise students to bring water from home, or to provide bottled water. If you do testing, lead release is sporadic. One-time tests are not conclusive for revealing lead risk. It's very possible to have a non-detect lead test one time, and then the next test you come back and have a high lead level in the water. So relying on testing alone to identify lead risk can result in exposure of our most vulnerable populations. So in this case, keep the water moving and use the certified filters, as Nancy had pointed out, the different certifications that you need to look for. As we're dealing with coronavirus, it's hands-free water is highly desirable. So many schools already have installed bottle fillers like the one that is shown here on this slide. It does provide an option to fill your bottle, and if there's a filter, even better, but absolutely need to have that filter there and make sure that parents and students know whether those are filtered or not. So as Nancy said, replacing and maintaining all the filter cartridges to ensure that they are operating as designed. And another point to consider and know as you are returning to school buildings is that many of those hands-free faucets with the motion detection for hand washing they're not required to meet lead-free requirements because they were never intended for drinking water. So very important to have clear signage that those those hands-free hand washing sinks should not be used for drinking water because they might have a high lead content. You might consider some of the flushing steps and the mapping and the planning. A lot of work, and it is, but this is an opportunity. This isn't just a one-time thing as a response to coronavirus. If you get a water quality management plan up for the school building and operating, you can use that, and you should use that forever and ever moving forward because these water quality issues are an ongoing thing. So any work that you do to develop these plans, communication protocols, how to talk to parents about the water, signage and filter strategies, these are all will benefit you in the long term. So parents might have some questions or want to ask about what has been happening in the school during the shutdown. So here are some questions that you might want to ask. Do you have a water quality management plan? Who is implementing that? Can you share a copy? How has the school been used during the shutdown, and what water quality maintenance has been going on during that time? And what flushing procedures have they been using? Questions about water testing. I think Nancy said we have no federal requirements for water quality testing in schools, in most of our schools. And so some schools do water sampling. They should share those results with the parents if they're doing the sampling. So definitely ask if that exists and make sure you get a copy of it. So have they done any water quality sampling? What protocols were used? What contaminants analyzed? You get all that information. Don't let them just trickle out, our water is safe. You get the underlying data and find out where those results are posted. Ask about how kids are using water at school and what the school is going to tell kids about that. Are they offering touch-free water? If they haven't been able to maintain water over the summer, what are they doing to tell students to bring their own water? Are they providing their own bottled water? Are they relying on students to flush their own water prior to drinking? That's a good question because we shouldn't put that responsibility on our children. And are they labeling untested or unflushed faucets for hand washing? And so just as kind of to wrap up what I've covered today, I want to cut schools a lot of slack. They are dealing with a lot of difficult decisions right now. Water is just one on a huge list of concerns they're dealing with, and it's very likely not at the top of their list. And so that is fine if they have not had the capacity to deal with it up until now. The most important part is clear communication with the student body and parents and the staff. So if they haven't been able to deal with water maintenance over the summer, that's okay. We can, start that going forward, but they need to communicate to staff and families. Tell them very clearly, bring your own drinking water, or we are going to provide bottled water. Don't drink the water in the school until we say it's okay. And of course, wash your hands. If they have been doing ongoing maintenance during the shutdown, tell everybody, let them know that we've been on top of this and you can trust the water, especially if we have filters in the school. Describe what the school has been doing. You can tell, you can use our bottle fillers. You can use these filter stations. This is where to get the drinking water because we've maintained that. You can also feel free to bring your own water if you're more comfortable with that, and wash your hands. So that is the end of my slides.
Great, thank you so much. If anyone has questions, please put them in the Q&A box right now and we will get to them. I wanted to quickly share that we also, some of the questions that Elin had in her slides, we wrote up on becausehealth.org. It's a 2-page toolkit that I'm gonna click on it so people can see, that talks about some of these issues in a way that's easy to download and send to a school administrator or childcare provider. And we have some links to things about flushing and testing, and then on the second page we have suggestions for what parents can do to protect their children, and then also very importantly a list of questions that parents can ask. So this is available both as a resource on the webinar page and on our website becausehealth.org. So I will now get to questions. Let's see. We had one question. Are schools generally regarded as high water use facilities?
I guess I'll try with that one. Compared to residential buildings, schools would be a higher water use facility, but compared to many commercial buildings, they wouldn't be quite as high. So I think in most communities, they would be kind of like a mid-range water user.
Okay. How does I think this question's for you, Nancy. How does the presence of water towers influence water age and quality?
I mean, it can. It depends on how it's linked in with the hydraulics. The map that I did show you is a community where a water tower has a huge impact on water age, a negative impact on water age. And so it's a water tower that is old, wasn't being maintained correctly, et cetera. So again, these are something that your water utility would know and need to be addressing to make sure that the water towers are actively moving water in and out and not being part of the stagnation problem. The cases when it becomes a problem is when you have the shrinkage. And so you have multiple issues in addition to maybe a water tower playing a role. If it's a community that has pretty well distributed population, I would say that's probably usually not going to be the issue. The water towers, there's a protocol for making sure the water is moving in and out of those towers. And they're really there to give you the pressure. And so they might fill it in the morning and then they're taking it out in the evening. So it's within a day when you've got the water going in and out. So in most cases it's fine. It's when you have a shrinking city that it can maybe be a problem.
Okay, we have another question about areas that are water stressed or in drought areas. In areas that are water stressed and have goals for conservation, How do you suggest balancing between flushing to achieve these water quality goals and conservation goals? And I think a connected question is, what can we do with the water that is used during flushing? Can we store it for other uses?
Yeah, I saw those. I think those are excellent questions, and I wish there was a magic answer to that one. You know, we've looked at using this water for flushing toilets, and right now, the way our systems are designed, we're using potable water for putting out fires. You know, for instance. So, you know, this is the way our system is. It's a centralized system. More of fit for purpose designs and buildings will hopefully bring to bear the notion of gray water reuse. There are some places in the country where they're starting to make progress with this, but our buildings are not designed for that. Elin, you probably have some comments on this as well. I think one of the things is that we're talking about some of this first flush water can be kind of crummy. And so you actually may not want to use it even to flush a toilet if toilets can actually aerosolize, or not aerosolize, but they'll produce droplets. And so depending upon if that water is of great concern, you may not even want to use it for that. But generally, it'd be ideal to find some reuse purposes. Elin, what do you think?
Yeah, I don't think we're there right now. And one of the challenges is how you have to move the water to each place in the building where there is an outlet. And that makes collection very challenging. So it's definitely an issue with the way our systems and buildings are designed. But hopefully, if we've got some creative people thinking about it, we can come up with new strategies in the future.
Great. Can you please address your best guesses about whether schools are currently aware of and planning to take some of these steps? Well, what's the education around these issues?
Do you want me to try?
Go ahead. I'm guessing that it's going to vary a lot. It depends on the school and their resources. And Elin and I are both in Michigan. I know we've worked with different school districts. Some of them the schools are so overwhelmed with so many different things. And I know air quality is it's a huge issue. And so thinking about water, and they're not water experts, I think it's a challenge.
Right. So I think I would doubt that this is high on their list of things to get ready for as students return. I know Michigan had a return to school roadmap, and the only time water ever appeared in the entire document was in regards to hand washing. So it's definitely something I think we need increased visibility of. I have seen water systems push out building plumbing guidance out to customers in general, like as you're returning to your office building, your school building, do these flushing procedures. But I think in schools, it's really important to get that communication out there, because schools are so overwhelmed and distracted, and it's yes, I think they deserve extra hand-holding and extra communication. So I think anything that we can do to improve getting messages out to schools and helping them with this would be great.
And I think here in Michigan, 4th grade discusses water. And so doing something with the kids, I actually am, Elin, I'm probably going to contact you, but doing some work that the teachers can use to help the kids understand water quality, and then they become part of the solution to maintaining the water in buildings. I think that can get us into the future on this, because as Elin said, this isn't just for the pandemic. This is something that we're going to need to do going forward.
Great. We had a question about who measures water quality after flushing? How many contaminants, and do you have a general sense of the cost of lab tests for these?
It's not monitored. It's not required to be monitored. And unless you have a budget within your school and you choose to do that, some schools have done that with lead for sure. They chose to do that. They were not required to. So it's expensive. It can be.
And relatedly, are any of you aware of where schools can turn to for funding sources to establish these flushing plans, for filters or for testing?
In Michigan, there has been some funding at the state level available for water quality plans and developing those maps. I'm not sure on the current status of that funding. EPA has been giving out grants for lead sampling in schools, and most states have received some funds for that, but how they're distributing that within each state is different. So that's what I know about the funding source for this. But back to sampling after flushing, disinfectant residual would probably be the indicator that you might use if you were to undertake that, because sampling and analyzing for every potential contaminant would just drain your budget. There's no way to do that. But if you've got a detectable disinfectant residual, it means you've got fresh water, and that disinfectant should be doing some work in your plumbing to control microbial growth. And so for those who can get a field monitor, and that could be an opportunity to work with, say, high school students to do some sampling inside the school.
That's a good point. Exactly right.
Okay. Can you speak to some schools or childcare facilities could be on well water that hasn't been treated from a public water system? How would you recommend they maintain their water system, and just some general comments about that?
Elin, you look like you have some thoughts.
My thoughts are, yes, that's a thing. So there are many schools that are what we call non-transient, non-community water systems, and those are subject to Safe Drinking Water Act regulations. And they have to treat their own source, and they've got, you know, more stuff going on at that school. But compared to the total number of schools that we're talking about nationwide, it is a smaller number. So I think they probably need some work. Usually it's the local health department or the state drinking water program that would be overseeing them. So definitely consulting with the state experts to provide that on-site assistance to deal with those situations.
And I think there's been work done recently, especially with those well casings and well water, to pay attention to lead on that. I think there's been more recent work showing that's a concern that perhaps has been under monitored. I'm sure there are maybe other factors as well for the water code, but definitely just the whole infrastructure associated with those wells should be tested.
Okay, great. Could you speak a little bit more about the filter first approach, and if this might be an optimal approach for schools to protect against certain contaminants like PFAS, nitrates, arsenic, and lead?
Elin, you've been a champion of that, please.
Okay, so the idea behind a filter first strategy for school drinking water is that there is lead throughout the school plumbing. So instead of trying to test for lead and figure out and just find it, install the filters that are certified to reduce lead in drinking water, install those filters to provide a safe source of drinking water in the schools now, and then hopefully work towards a future when we can remove lead from all of our plumbing, so that when we replace school plumbing, there is no added lead in them, that those products are currently not available. So if a school is interested in that strategy, it's very effective for reducing lead in drinking water, and depending on the treatment, the filter cartridges they get, they can be certified to remove additional contaminants. So schools can look at, you know, what contaminants are we concerned about? Is it lead plus others, or is it just lead in our school plumbing? And find the products that they need to reduce those, and have those filter stations, and have those be your designated drinking water points, and use all your existing taps for hand washing so we can prevent the spread of coronavirus.
Yeah, I'll say with regard to PFAS that the conventional carbon block filter will remove some of the medium size kind of the PFAS of concern, but it's not highly efficient. And so you're going to have breakthrough, if you will, of PFAS, I think, before you would lead. And so ideally your centralized system is dealing with the PFAS. And that's a lot of communities are looking into this right now. They're starting to deal with this. I know we have this in Ann Arbor where our utilities been working towards this, but that's a new challenge. And I just want to be clear about that the point of use activated carbon black filter isn't the best, most efficient way to remove PFAS. Unfortunately, something like reverse osmosis is better, but that's very expensive.
Okay. We had a clarification question on the hydration stations, like the one that you showed with the bottle filter. Is that considered a point of use filtration system, even though the filters are not at the tap, but rather internal to the fixture? And is there a risk for lead contamination beyond the filter in the hydration stations, since the fixtures manufactured today may contain up to 0.25% lead content? And does the fountain portion use the filter as well, or is it just the water bottle portion?
It depends. So we would consider that absolutely a point of use filter, because the filter is at the that point of use rather than point of entry. That's kind of the distinction that we use, but there is definitely a short tubing between the exit of the filter cartridge to the outlet where you would actually fill the water bottle. So in many, if not most cases, it's plastic. It's a short length with a short volume. If the user flushes that at the beginning, that should not be an issue. It'd be only if that water was in contact for a long time. There's still kind of working on some of these unknowns about that impact. So far, I haven't seen any data from these filter stations that indicates that it is a significant source of lead. I'm still working on collecting more data on that. Then the question about whether it is both the fountain and the bottle filler that have the filter, it all depends on what unit it is, what the plumbing setup is. I know for certain in my children's school, they have installed filtered bottle fillers right on top of an unfiltered drinking fountain. And there's a metal panel. It looks like it's a one continuous unit. They are not. The fountain is unfiltered. The bottle filler is filtered. So it depends answer.
Okay, great. I actually have a question. Are your recommendations also applicable to small business owners, retailers, office buildings?
Yeah, these are most of what I've included in my slides are all combination from various building plumbing flushing guidances. And I think your information sheet has linked to most of them, and I have links in my slides to those resources. So yeah, the idea there is similar. More complex office buildings should have somebody who's in charge of the water there. So hopefully they have a building engineer to do this. But yeah, definitely small businesses and less complex plumbing, those business owners would want to be implementing this type of work to turn over the water in their buildings.
Okay, some of this is ask questions and but be a partner with the people who are maintaining the facilities, or at least start there, because they need, I think, those positive partnerships. You know, I think the point about the hydration station, Elin, is an excellent one. The ones that I've worked with have used the filter for both the bottle filler and the bubbler. Mm-hmm. It's horrifying to think of one that's not like that, and why anybody would even do that. But the fact that you found one suggests that we have to pay attention. And I've gone into my child's classroom and opened the cabinet to see what's underneath the sink when they added filters, so that I understood what was happening. And I think schools need to be open to that. The parents know, and there needs to be just transparency. And I think you'll be a much better partner with your parents if you're kind of transparent. Here's what we know and here's what we don't know. And because of that, you know, you can bring water from home. You can do this, you can do that.
Okay. We're at the end of our time, but I have one last question. What policy changes at the federal or state or even local level would you recommend to better protect water quality in schools and childcare facilities?
I want to applaud Elin and her leadership on the Filter First effort, and there have been others involved in that. But it stops this this idea that we're going to monitor and figure out what all the problems are is kind of crazy. The notion that we know premise plumbing, a lot of schools are old, etc. Let's just stop putting all the money into trying to figure out which faucet has what and use filtering and best practices and water management plans. And those kinds of policies, if those are local, I think that oftentimes that's where the rubber is going to hit the road fastest. But Elin, you have a lot of experience with this.
Let's see. I think focusing on providing safe water to kids now is the way to go. It's going to be a lot more effective, and it's because our kids are young now. They don't have time to wait until they're older for us to do better in our school drinking water. So that filter first strategy is good, especially for lead. And it's just this challenge of the water quality in the buildings and making sure it gets used. There's some, the federal lead and copper rule revisions that were proposed last fall include some sampling requirements for lead in schools. Those sampling requirements will not reveal lead risk. They will not be informative. That's not well designed. I'm hoping they come up with something different when they finalize that rule. So it's how we do this is going to be important because schools don't have money to waste on ineffective strategies for safe drinking water.
Okay, great. Thank you both so much for joining us today and sharing your knowledge. Hannah, I'll turn it back over to you.
I want to thank both the speakers. You guys are sort of heroes of mine with small children at home and in school, thinking about them going back. So thank you for all of your work continuing on these efforts. Thank you, Karen, too, for moderating. We are approaching the end of today's webinar. A video recording will be available on Chay's website soon, and tomorrow you'll receive an email containing a link to the video. Our team has been busy planning the fall webinar lineup, including a new Chay UCSF program on reproductive health and the environment and the Earth Center partnership 7-part webinar series. Details will be announced in the coming weeks. If you are new to Chay and would like to stay updated about upcoming events or more, please sign up to receive a newsletter by selecting the Join Us tab at the top of any page on our website at healthandenvironment.org. Additionally, if you appreciate these Chay partnership webinars bringing you the latest environmental health research for free, we encourage you to support Chay's ongoing work by making a tax-deductible donation via our secure website. Again, our website is healthandenvironment.org. With that, I would like to thank our speakers, Dr. Nancy Love and Elin Betanzo, for taking time today to present, and to you, Karen, for your excellent moderation. Thank you so much for joining us. Have a great day. Stay well and healthy.